You know, your body has this incredible guardian. It's a super sophisticated, microscopic army that's on duty protecting you every single second of every day. But what happens when that guardian gets it wrong? When it's too weak, maybe too aggressive, or just completely confused? Well, we're going to dive into this complex world of immunopathology, where that line between guardian and threat can get dangerously blurry.
You know, this one sentence from our source material just absolutely nails it. It perfectly captures what our immune system is all about. It's our greatest defense, for sure, but it can also be the source of some really profound injury to our own bodies. And getting this duality, that's the key to tackling a huge range of diseases, from allergies and arthritis all the way to cancer and AIDS. Okay, so take a look at this. This flowchart is basically going to be our roadmap for this whole explainer. As you can see, our guardian can go wrong in a few key ways. It can be too weak, way too aggressive, or just totally confused about who the enemy is. But before we get into all the ways it can fail, we really need to understand the system when it's working perfectly.
Right, so before we can really get into how things go wrong, we've got to appreciate just how complex this system is when everything's going right. So let's meet the soldiers on the front lines and take a look at the brilliant strategies they use to keep us safe.
So our adaptive immune system, the specific one, it's got two main game plans. On one side, you have humoral immunity. You can think of this as kind of like long-range warfare, where B cells are producing these antibodies to tag and neutralize invaders from a distance. And then on the other side, you've got cellular immunity, which is all about up-close, hand-to-hand, cell-to-cell combat, led by the T cells.
And here's the crew. These are the key players on the team. You've got the lymphocytes. They're like the special ops forces. Then you have the macrophages, who are kind of the battlefield medics and the cleanup crew all in one. And backing them up are neutrophils and mast cells, your frontline infantry and the guys who sound the alarm. Every single one has a critical job to do.
But out of all these different cells, the lymphocytes, man, they are the undisputed masters of the whole operation. T cells, which make up something like 75 to 80% of all lymphocytes, they're the field commanders. Meanwhile, the B cells, at about 10 to 15%, they're the weapons manufacturers, just churning out those critical antibodies.
Okay, so this is the really big question, right? How in the world do these cells know who to attack and who to just leave alone? Well, the secret is a unique biological ID card, and the blueprint for it is written right into our genes. It's located on chromosome 6, and a set of genes called the HLA system is what generates this ID for every single one of our cells.
Now, this HLA system also goes by another name, the Major Histocompatibility Complex, or MHC for short. Its job is to create these proteins that sit on the surface of our cells, constantly telling any passing immune cells, hey, I belong here, I'm self, move along. This is precisely why matching MHC types is so incredibly important for organ transplants. If there's a mismatch, it basically screams, foreign invader, and triggers a massive immune attack, what we call transplant rejection.
All right, so we've met the Army. Now let's go back to our roadmap and look at that first path to disaster. What happens when the Guardian just isn't there?
I mean, it's a pretty terrifying thought, isn't it? What happens when this complex, powerful guardian is crippled, or just missing in action? Well, the consequences, as you can probably imagine, leave the body totally defenseless against even the most common germs.
Well, that state is called immunodeficiency. And honestly, there's no more devastating modern example than acquired immunodeficiency syndrome, or AIDS, which of course is caused by the human immunodeficiency virus, HIV.
HIV. It is an absolute master strategist. Its plan of attack is just diabolically brilliant. First up, selective tropism. It doesn't attack just any cell. It specifically targets the CD4+ T helper cells, the commanders of our immune system. Once it's inside, it pulls off this terrible, brilliant trick. It converts its own RNA into DNA and then splices it right into the cell's own genetic code. And just like that, the cell becomes a traitor, hijacked from the inside, and is forced to just make more and more of the virus until it's destroyed. So what you get is the systematic, just devastating wipeout of these T helper cells. By taking out the commanders, HIV doesn't just fight the army, it completely dismantles the entire chain of command, leaving the body pretty much defenseless. And that brings us to a really critical number. When a person with HIV has their CD4+ T cell count drop below 200 cells per microliter, down from a healthy count of, say, 500 to 1500, they are officially diagnosed with AIDS. At this point, the immune system is so weak that the body becomes vulnerable to all sorts of infections and tumors that a healthy system would just brush off without a problem.
Okay, so that's one edge of the sword, a guardian that's just gone. But the other edge, it's every bit as dangerous. What happens when the guardian is too present, when it gets overactive, or worse, confused? So this first kind of overactivity is what we call a hypersensitivity reaction. This is basically when a normally protective immune response becomes completely exaggerated. The system spots a threat, like pollen or a bee sting, but the response it unleashes is so way over the top that it actually causes damage to our own tissues. It's a total overreaction.
Now, these overreactions get sorted into 4 main types, and what's super interesting here is the timing. Just look at that peak time row. Type I reactions, like a peanut allergy, are almost instantaneous, but a type 4 reaction, like the one you get from poison ivy, can take more than a day to even show up. This tells us our immune system has different weapon systems, some that are incredibly fast-acting and some that are slow and deliberate, and any one of them can go into overdrive.
But then there's this other type of malfunction, and this one it's even more profound. We're talking about autoimmunity. This isn't just an overreaction to something from the outside. This is a fundamental failure to recognize self. The immune system completely loses its tolerance for its own tissues and starts seeing them as foreign invaders. It's the ultimate betrayal, friendly fire.
Man, the list of autoimmune diseases it's staggering. They can attack pretty much everything from our joints and our skin to our most vital organs. For our purposes today, we're going to zoom in on systemic lupus, or SLE, because it's a classic example of how this internal betrayal can cause damage all throughout the body.
This is just incredible. In SLE, the immune system starts pumping out these autoantibodies that go after the most fundamental parts of us, even our DNA. It's literally creating weapons designed to attack the very blueprint of life itself, and that leads to widespread inflammation and tissue damage.
So, we've looked at what happens when the system is too weak and what happens when it's way too strong or just plain confused. Let's kind of pull it all together now and think about this incredible balancing act our immune system has to maintain.
So if we circle back to our roadmap one last time, it all kind of clicks into place, right? Immunodeficiency is the story of too little defense. Hypersensitivity is the story of too much. And autoimmunity is this tragic story of confusion, where the system ends up attacking itself.
But hey, take a look at that 4th pathway, possibly immune. This is where you find these really mysterious disorders like amyloidosis. This is where abnormal misfolded proteins start building up in organs like the heart and kidneys, causing them to fail. We suspect the immune system is involved somehow, either by failing to clear out these toxic proteins or maybe by contributing to the inflammation that creates them in the first place. It's a fascinating frontier and a humble reminder of just how much we still have to figure out.
So you see, our immune system is constantly walking this razor's edge between being our friend and our foe. And that leaves us with a pretty deep question. If our own protectors can become our worst enemies, what does it truly mean to